want to tell you the tetrapod limb early theory because this is going to make the rest of it make a lot more sense. So before we totally understood how the autopods got those 5 parallel bones in them, the forelimb got its 2 parallel bones, and then the upper part of the arm got its 1 big bone, this was the kind of the theory that was going around. Now, this is actually pretty old, I think from the 70s or so. And this is what I was taught because when I was an undergraduate, we actually had no clue what all of the genetic elements were underlying the limb. We knew about the AER and the ZPA, but we didn't know all of the rest of the patterning elements. All right, so early theory. So I want to start out with the small limb bud early in development. Okay, so here is our small limb bud early in development. And now we're going to put inside of it our SOX9 tissue, right? So this is going to be our tissue that makes bones, skeletonergic elements. It's going to start out as cartilage. And this tissue is going to be a self-inhibitory tissue. So you have a block of it, but then it makes a ring of inhibition around it. So I'm going to make the ring of inhibition in yellow around it. Okay. And this is going to prevent any new blocks of tissue from coming about. So this is going to be basically a really simple system where you've got a black block of tissue that inhibits the formation of new blocks of tissue. Okay. So this is going to be the humerus. So our growth is going to occur in this direction. But we're also going to be getting growth in these directions and in these directions to a lesser extent. So we get a lot of growth in this direction, okay, away from the body, but then of course we get cell proliferation to make the limb bud bigger in all dimensions at a slightly slower rate. Now the consequence of making the limb bud bigger in all directions is that we're gonna start to have room for more of these black blocks of tissue. So let's make our next limb bud. It's gonna be a little bit longer, and it's gonna be a little bit wider. Okay, so it got longer faster than it got wider though. And so we're gonna have, I can't show all of it here because I simply don't have room. We're gonna have this block of tissue here that also got bigger and wider, and this is gonna form the humerus. But now over here you can see, so you see the size of this guy, we have room for 2 blocks in this tissue. Okay, so we get 2 blocks here. These are a radius and our ulna. So this patterning really explains how we get 1 big bone here and 2 littler bones here. This is just because the zone of inhibition from this block reaches around like this, and the zone of inhibition for this block reaches around like this. Okay, so there's now room for 2 different blocks of this skeletonergic tissue. So what happens when we get to the hand? Well, the hand is a little bit different because the hand develops in a sort of paddle shape. Okay, so now we're just looking at the hand. We have to imagine all of this other stuff behind it. We're going to look at the hand. Now, see, this is sort of a problem because when we start out, we have room for, let's just say we have room for 3 elements, okay? But as the petal grows out, it's now growing much faster in these directions than it was before. That's giving it this paddle shape. And that means that as it grows out, we have room for more and more of these little elements. Okay, so we might have room for 4 here, we might have room for 5, etc., etc. And so by this simple model that really helps to explain how we get the humerus and then the radius and ulna in parallel, we would expect to get a hand. Here's my paddle-shaped hand. What we would expect is a hand that actually has branched elements in it. Okay. So here's my branched elements in my hand. Okay, so as it gets bigger, you have enough room that the zones of inhibition kind of go away. And you might even get some elements. So I'm going to draw this one over here as a non-branched one. You might even get some elements sort of peeking up as the tissue gets wider and wider, and your zones of inhibition, right here are my zones of inhibition, they can't cover all of the territory, okay? So that allows for the formation of these new skeletonergic elements because the zones of inhibition only reach so far. So we have this mechanism that can explain this pattern, but if we try to apply it to the autopod, we get this branching issue. And so how to explain how we only get those 5 fingers, so what we actually see is a paddle with our 5 elements as sort of wedge shapes in it. I'm going to draw it so badly. I'm going to give it a try though. Okay, here we go. There we go. So what's actually happening here is that we're kind of maintaining the zone of inhibition, but we're changing the shape of these elements. Instead of being blocks, we're now making them wedge shaped. And so the question is what's allowing them to do that? So we don't get what we expect, instead we see this.